Number two, this function is already simplified for us. Okay. The biggest things that will affect the symmetry are if you have a shift horizontal left to right, that means something in parentheses with x, or the +3, depending on which type of symmetry you have. Let me just give you the full blown. So when we start talking about symmetry and transformation of functions, the general form of a transformation is this. We'll just say b x minus h, and then plus k. Okay, if you have something like this with a shift left to right, this will affect even graphs. Okay, so if a graph was even according to the exponent, and you have something like this, that will affect it, which means it will no longer be even. This will affect odd graphs. And also x-axis. Trying to squeeze this in. Okay, so that will kind of help you have an indication of what type of symmetry you will have, or how it will be affected if you had one such symmetry. So this, again, I know is a parabola. It will be a U shape. All it does is get shifted up. So being familiar with the graphs will help. So I have a parabola. This will just make it, a horizontal stretch, if you will, that won't really affect the layout where it is as far as symmetry. This guy will just shift it up 3. 1, 2, 3. So before, this graph was symmetric across the y-axis, and then it is still symmetric. All we did was move it up or down. The moving left or right, which is what this does, will affect even graph. I know it's even because of this, and it will still be even because this 3 doesn't affect the symmetry about the y-axis. Okay, but let's see it with algebra as well. So we have our r of x. We're going to do r of negative x, okay, which just means I'm going to replace the x with a negative. So I have a negative out front, and then instead of x, is going to be replaced with a negative x, still squared, over 2 plus 3. So that negative is going to get squared, which is going to let it remain positive, so that negative outside is not affected. This will become positive. That will still be 2, and then plus 3. So now if you look at this equation with algebra, it looks exactly like the same thing. Even after I plugged in the negative, I simplified it exactly the same. So these two are the same, means even. So remember all those functions. F of x is equal to f of negative x, and then you have f of x compared to negative f of x, and then you have f of negative x compared to negative f of x. Okay, so right now we've compared these two, found out that it's even. Okay, now I'm going to do this one. So I'm going to do negative r of x, which just means I'm going to multiply this whole side by negative. So everything I had, which was a negative x squared over 2 plus 3. So I'm going to distribute negative, so all signs are going to change. So a negative r of x. I'm sorry, you can't hardly see all of that over there. But negative r of x, negative times a negative, that's going to become a positive x squared. And then negative times that, it's going to become a negative 3x. So here's your negative r of x. So now I want to compare my original up here, which you can't see. I'm pointing at it. Your original one right here compared to this new one. That is negative. This term is positive. They're not the same, so it's not odd. No. And then I'm compare these two to see if it's, sorry, this is x-axis, not odd. It doesn't have x-axis symmetry. X-axis. Okay. The odd one here is here at the bottom. These two make it odd. So now we're going to compare this one and this one. And so since they were the same, there's no way that these are the same. You can see the negative and the positive. So it's not odd either. So this graph is even, proved by algebra, and also just confirms what we were thinking with the transformations and shifts. So even. All right, so with this one, this one, the highest degree is a 3, which would indicate leaning towards odd, okay? But, okay, recall this little image. I was trying to show you that if you have some number being added to the back, not in grouping symbols, parentheses, fraction, a square root symbol, whatever the grouping symbol is for that function, this will shift it left and right. This will shift it up and down. This will affect odd and x-axis. This will affect even. So we have odd. And do we have something at the back shifting it up or down? Okay, yes we do. So let me give you an image of what that looks like and describe that. And I'm going to solve this one more time for you, and then I'm going to allow you to practice these on your own, and I'll explain them and try to go through this a little bit more quickly. So with number 3, we have an f of x equals x cubed over 4 minus 2. Okay, so what that graph looks like, x cubed, physically, how do you know this is odd? Okay, if you imagine flipping this across the y, you would get something like that. And then you flip it across the x and it matches, then it's odd. And you could do it the same way. If I flipped it across the x first, it would look like this. Okay, mirror image. Okay, so imagine just flipping it straight down and then flipping it across. That would match perfectly. So you flip it both directions. You can do y then x, or you can do x and then y. If it matches, then it's odd. Okay, so this is what that graph would look like. Now, if I were to take this graph and move it down 2 units, 1, 2, and I'm going to do it in red. This graph would be going up like this, and then coming down like this. It no longer fits, okay, because if I were to flip, let's just say this little section here, because every section has to match. If I flip that across the x-axis, I would have this piece going right here. Like a little U-top. And then if I flip that across here, it would look like this. It would be coming down, almost like making a circle. And that is not the image that we have, okay? I don't have that piece. So you flip it across, and then you flip it up. There's nothing there. So whenever you shift it up and down, it moves it from its center to where it was flipped directly across. So this is no longer odd. It has lost its symmetry because of the transformation. However, you can also verify that with algebra. So I'm going to do both of them. I'm going to do f of negative x, and I'm going to do negative f of x, that is. So when you plug in a negative to an odd, it's going to change signs. So an odd power will change signs. So I plug in a negative, it's going to become a negative x to the third over 4 minus 2. So here's that function. Here's my original function. And then a negative on the outside, you just change all the signs. So this is going to become a negative x to the third over 4. And then that's going to become a positive 2. And so we compare these two to see if it's even. Are they the same? No, so it's not even. Then I compare these two, top and bottom, to see if it has x-axis. Are these the same? No, positive and negative. So it doesn't have x-axis. And then I compare these two to see if it's odd. And are these the same? Those are both negative, but this is negative and that's positive. So it is not odd. So this graph does not have any symmetry, x-axis, y-axis, which is even, or origin, which is odd. So it has neither.